Hi there, I'm Len Shaffrey. I'm from the National Centre for Atmospheric Science and the University of Reading. And I'm going to be talking to you today about drought forecasting. So we know that droughts can have substantial impacts on agriculture, on industry, and on human health. So for example, the 1976 UK drought cost UK farmers about £400 million in reduced crop yields. One of the key ways to mitigate the impacts of drought is to prepare for them. And this raises the question, how far in advance can we predict droughts? Now, the first thing to say is that droughts are really slowly evolving events. In the UK, we have to receive lower than average rainfall for a number of seasons before we start to worry about drought, with the rule of thumb being that we need 2 dry winters and a hot summer before drought conditions occur. So to predict droughts, we need to forecast what will happen to rainfall, to river flows, and to groundwater levels in the next few months. In the IMPETUS project, we've been looking at improving forecasts of drought on monthly to seasonal timescales and understanding how water companies, water regulators, and the farming sector can use forecasts to best plan for and to prepare for drought. In terms of improving drought forecasts, there are really 2 aspects. The first is improving forecasts of river flow and groundwater levels. It takes weeks to months for hydrological systems such as rivers and groundwater aquifers to dry up. The memory in hydrological systems means that if we know what conditions are like today, we can use hydrological models of rivers and groundwaters to predict how they will evolve in the next few months. In IMPETUS, we've been improving hydrological forecasts for this very purpose. So for example, the figure here shows some work done at the Centre for Ecology and Hydrology in terms of forecasting river flows using hydrological models. The blue dots show where the models are skillful for 1 month ahead. And you can see that right across the UK, we've got skill in terms of forecasting river flows, particularly for England and for northeastern Scotland. The second aspect in improving drought forecasts is to improve forecasts of rainfall. This is very much an emerging area of science. In the past few years, climate scientists have shown that there is some skill in forecasting the large-scale wintertime atmospheric circulation over Europe a few months in advance. This particularly arises in terms of forecasting what's known as the North Atlantic oscillation. Now, the North Atlantic oscillation is a large-scale mode of climate variability over the North Atlantic. This figure here shows what happens when the North Atlantic oscillation is positive. We have increased flow over the North Atlantic, which brings more storms and wet conditions into the UK. When the NEO is negative, we have the opposite, and we have storms going into Southern Europe, and we have dry conditions over the UK and Northwestern Europe. In IMPETUS, we've been using seasonal forecasts of the wintertime North Atlantic oscillation to actually generate skillful forecasts of rainfall for the UK. In IMPETUS, we've also shown that skillful forecasts of summertime rainfall in the UK are possible. We can make forecasts of rainfall for July and August using preceding springtime, March and April North Atlantic sea surface temperatures. However, though all forecasts of rainfall are skillful, there's still a notion of caution that currently seasonal forecast skill is still quite low. The other aspect of seasonal forecasting that we've been looking at in IMPETUS is trying to understand how water companies, water regulators, and the farming sector can use drought forecasts to best prepare for and to plan for drought. Researchers in IMPETUS and the UK Drought and Water Scarcity Programme have held workshops with water companies, with government departments, and with water regulators to understand how they might best use forecasts. There are exciting opportunities to use the new science of seasonal forecasting, but there are also real barriers in terms of their uptake. Some of the key things at the moment is that forecasts are not skillful enough in order for them to use them for operational decision making. There's also questions about risk and regulation. So water companies, not surprisingly, are very risk averse around drought. So what use would a forecast be for drought if we're already going into drought forecasting situation? And finally, there's questions around operationalizing forecasts. So are forecasts presented in the right way? What information do water companies and farmers need in order to use those forecasts? So just to summarize, in IMPETUS, we've been improving the science of drought forecasting. We're also trying to understand how people can actually use drought forecasts to plan and to prepare for drought. So I hope you found this presentation useful. If you'd like to find out more about the science of seasonal forecasting and what we've been doing in Impetus, then visit the About Drought website, www.aboutdrought.info, for more information.